Hello everyone. So we will be looking at how to create an NFT and mint it on Polygon network. For this, we'll be using openzeppelin contracts. They already have a few boilerplates defined for us. We'll be using it in our NFT contract, and we'll be creating it. So the standard which we're going to use is ERC721. For that, what we're going to use today is like we're going to use Hardhat for building our contracts and deploying it to Polygon testnet, which is basically a Mumbai testnet. So, in order to create a Hardhat project, so I already have npm installed, so I can just use it by nvm tool. So I have a Gallium LTS Gallium version installed. So if you guys want any documentation on how to how to install NVM and use it, so there is this documentation here. They have a GitHub repo. So they have all the installation details for different platforms and how to add it to our batch file or the GRC file. So that being said, let's get started. So basically, to use a Hardhat utility, we'll be using this npx tool. So if you do npx Hardhat, it will give you a few comments saying that do you want to create a basic project or do you want to create an advanced sample project. We'll go ahead with advanced sample project that uses TypeScript. So here they will have all the utilities that we need. We already installed. Let's do it. It's also going to have a few linters for our TypeScript. So we will be basically using the TypeScript to compile and deploy the contracts. So when we get to that point, we will understand how it's done. So when we talk about deploying the contracts, so we are doing it using Alchemy. Alchemy is basically a build system. They also have a lot of other utilities when it comes to blockchain application development. So it's basically like free to use. Just go ahead and log in yourself, register yourself, and go to the dashboard. Here I already have created an app for this tutorial. It's called the 3 tutorial. So in this tutorial, I'm not going to show you guys any front-end development. I'm just going to show you just the contract part of it and how to deploy it and how to mint it. I'll be minting it via our deployment script itself. I'll if we have enough time now, I'll be showing you how to interact with the contract this JavaScript console. This is going to take some time. Meanwhile, we'll see how to create an app in Alchemy. You can just go to the apps section and click app. You can just give name and description for it. So when you come to the chain, like there are like multiple chains they support. I'll be choosing Polygon. And, I'll be choosing Mumbai network. And the environment they're going to use is development as of now. And once that is done, you can just click on create app. So after that, there will be an app appearing in the app section. You click on your app that you created. There is an option called view key. So you click on this view key. This key is what we're going to use to connect with this particular app from the Hardhat project. So I'll be showing you how to do it the moment the project is ready. Also, I recommend you install some web wallet. So in my case, I'm using MetaMask. So it could be Binance or it could be metadata. So what we need is we need the private key, but it's not advisable to store the private key somewhere in the code that you share it with someone else. It is always recommended to keep the private key hidden. But what we're going to do is like we're going to connect to this account. For that we'll be requiring the private key. So what I will be doing is I'll be like copying the private key and putting it in the env file, which I will not be uploading it to the GitHub repository, so that I'll be excluding the env file, the environment file. I'll also show you what the environment file is and how to access variables from the environment file. In a moment. Okay, our project is created. So I'll open VS Code. Let's open another window. Alright. So when you look at the env.example, there is an example file which is already comes with the boilerplate code the Hardhat is providing. So there are few URLs here, something called Robson URL. They have this template. There is this API Alchemy key. That's the key we're going to get from the Alchemy dashboard. And there is a private key, which is not the real private key, but it's just a sample private key what this boilerplate is giving us. So I'll be replacing this private key with my own private key. When you look at the private key, it will not have the 0x prepended. What you have to do is like you just have to delete everything from this point till the end, after the x till the end, and paste the private key from your MetaMask wallet. So to get the private key, what you can do is like you just go to MetaMask. So I've connected to the Mumbai network. I've added Mumbai network to my MetaMask, and you need to check the account details. So there is an option called export private key. I'm actually going to do it. I'm not going to record it. So once it's done, you know what, I will not be coming back to this env file. Maybe you guys might see what the private key is. And anyway, I just use that account for testing purpose. I don't have any real value stored in it. Still, but I'm going to copy the Mumbai URL and store it as Mumbai URL and paste it here. Yeah, we are not going to use this option URL, so let's leave it as such. So things are happening the other end. So let's start. Okay, what I'm going to do is like once I have the env file already, I'm going to copy it into another file called .env. So this is the command that I use to like copy a file from one file to another. So once that is done, what I'm going to do is I'm going to remove my .env.example in this case. That's going to remove the file. Alright. So before we get started with the contract development, we're going to do a few setups. So if you look at the file structure, there is a file called hardhat.config.ts. So this is where we're going to add the network that we're going to use. So what I'm going to do is I'm going to add another network in Mumbai. So these errors actually pop up because of the length which the project is already had it. So let's ignore them for sometimes they'll actually disappear and do things correctly. So the name I gave in the env file is Mumbai URL. If that is not there, it's going to append it with the default empty string. The accounts, I'm going to use this. I have the private key variable set, which is basically not equal to undefined. I'm going to take the undefined. I'm going to read the env and the private key from the env file. So if that private key is not there, I'm going to just give it an empty array. Yeah, I think now we're all set. So let's try this setup once and let's check whether this is working. So what I will do is, like, there is already a contract that is coming with the boilerplate. It's just like a greeting contract, which basically what it does is like just create a string. I mean, just setting a string and just getting a string. So this doesn't do anything fancy. It's memory variable, and then yeah. So what we're doing is like we are just changing the variable. I mean the value in the variable that's stored in blockchain. So it's basically for setting anything, we have to pay gas fees here, and for getting a variable for reading a memory variable, we don't need to pay any gas fees. So that's the rule of thumb. What I'm going to do is I'm going to check that this particular contract is actually compiling, and we're able to deploy it to the Matic testnet, so that we'll know that this entire setup which we did right now is actually working. So for that, what I'll be doing is like I'm going to be showing you guys the polygon scan, the Mumbai polygon scan, and there will be some logs that are getting generated when we do any transaction. So in order to do that, what I use my default console. So what I actually do is I have an alias created already. So when I type HH, which means npx hardhat, so what I do is I just type compile my entire contract code. Nothing has changed there. So what this basically does is it creates some bytecode and opcodes. They're all stored in the folder called artifacts, which will be created in a moment. You can just go ahead and look what the artifacts are actually giving us. So if you look at there are like a couple of folders that is created after the compile command is completed. So one is cache and another one is artifacts. So inside the artifacts, if you look at the directory, there is something called contracts. So when you go into the contracts, so there is a JSON file with the name of the contract file. So when you open it, it's going to have a JSON structure, which is going to have bytecode, the actual deployed bytecode. So there is something called an ABI. This is what we are very much interested in. So if we are going to build a front end for this contract, in that case we'll be requiring this ABI as well as the address of this contract that is being deployed. But as of now, we do not have the address with us because we haven't deployed the contract yet. But we have the ABI ready, so we can use this API. So what we can do is like, I'll again go to the console, and now I'm going to deploy this into our Mumbai network and Mumbai polygon network. So for that, what I'll be doing is like npx hardhat. I think maybe for beginners I have to show them actual what command I'm using. So I'm using the run subcommand with the network flag. In the network flag, I'm going to give Mumbai. So this name is actually coming from config file, the config.ts file. This is the name that I'm giving. When I give it, it's going to say that the URL is going to be the Mumbai URI from the env file, and the account is going to be the private key which I've added. And then so for the run command I need to supply a script as an input. So script I'm going to be supplying is in the scripts directory. These scripts, what they will do is like they'll basically deploy this creator contract to a particular location. The address is automatically created, so we can get the address and we can actually look at it. So far what I'm doing is like I'm just trying to test the setup. For starters, if you guys really don't know how to do this setup, so if you guys really know how to do these things, you can skip ahead and you can go to the section where we actually start developing the NFT contract and deploy it. So for that, what we're going to do is like since I said that we're going to be using NFT ERC721, let's go ahead and check what the ERC721 standard actually says. We're going to go to the EIP. So this is like a guide where you can come back and check what the actual contract is going to be like, what are all the methods that's available, what is the interface that they are doing, everything. So we are not going to use all the methods here and all the events here. For starters, we're just going to keep things simple. For that, so that being said, let's first look at what this actual contract means. So it's the implementation of standard API for NFTs within smart contract, function to track and transfer NFTs. Okay. So by the way, I assume that since you guys are here looking for an NFT creation, I believe that you guys know what an NFT actually is. So that's why I have not gone into any details of that. Maybe if you guys don't know what it is, you can put in the command and explain what the NFTs are, where they're actually used, and how we can leverage the power of this NFT and use it in our platform, things like that. So, let's check. Okay, it says like the contract has been deployed to this address. Let's go to the testnet, paste the address and find out. Yeah, so this is not something that I wanted to teach you guys basically, but for helping the starter now, I'm just showing you how to deploy a contract here. So the verification process is another thing. What you can do is like you can just verify, and you can actually see the methods here, and you can interact with the contract from here. That maybe I'll show you guys in another video. So here, coming back to our NFT. So basically what we need, the primary thing for creating an NFT is the tokenURI. So if you see here, it says like a distinct uniform resource identifier for a given asset. So the asset that we're going to create is going to have some properties. Let's say that property is in the form of a JSON file. So basically this URI is going to define the metadata of the asset. So it has to be stored somewhere. When it comes to decentralized web, we cannot store these assets in a centralized server, which is not the right way to do it basically. Yes, we can, but that's not what we do. So what we can do is like this is like a sample JSON format for an imaginary NFT. So this JSON is stored in a place called IPFS. So basically it's a decentralized file store where files are like not stored in one single place. You get an IPFS URL. We can use that URL as a token URL. So that is a different that will take a different tutorial to show you guys how to create an IPFS file and how to create a file and upload it to IPFS network. So for starters, I have already created one file having a metadata which has a URL. I will just show you guys. So what I'm doing is I'm just using this IPFS Explorer in my local machine. If I go to the files, I have these files. So I have created this pirate.json. So I have the avatar in this location. If you go to this location, you can actually see the file. He has some attributes. He also has some assets with him. So to view this URL, let's say on share file, I'm just gonna copy it. I can just directly paste the URL in the browser. With the JSON format will actually be displayed. This is the raw format. So there is this avatar file which is also an IPFS URL. If we click on it, it displays an image. Basically, this image is from a free pick platform, so I believe we can use it in our video, in our tutorial here. I know he doesn't look like a pirate, but I'm just imagining he's a pirate because I didn't get a close-up file that resembles a pirate. So yeah, so what we'll be doing is like we'll be implementing this URI function, token URI, and then we'll be giving a name and symbol obviously for our NFT, and then yeah, that's it. So like I said, I'm just going to keep it very simple and explain the function that we're implementing as we are developing the contract. The SOL is the file format for Solidity. I'm just creating a file called NFT contract.sol. It basically creates an empty file, so we just have to mention the licensing for this file. I think it's XPDX license I25. Okay, these things might little tricky. If you look at the documentation, they'll explain why we need to set our licensing stuff in all the headers, all the files. So one simple, one heads up is like, let's say I'm setting this MIT as a licensing identifier here to the greeter contract. I do not have an unlicensed one. So let's say, maybe not now, maybe later in this tutorial we'll be looking at how to create a counter. So I forgot to mention one thing. So I said here we'll be using this token URI. So when you look at the parameter here, there is something called a tokenId. So this tokenId is a uint256 variable, a type, which means this is number, which is going to refer to the token URI. So in that case, we are talking about a mapping here inside this NFT. So the mapping will have tokenId as a mapping variable to an URL. I'll show you guys how to do that in a moment. So for this tokenId, what we need is we need a unique identifier basically. There are so many ways to create a random, truly random number in blockchain. One great example is using the chain link VRF, I think it's called chain link VRF coordinator. So basically what this one does is like it creates a truly random number for tokenizing our asset. So only then it's called the asset is basically a unique asset. Else it does not resemble the uniqueness in the NFT world. So maybe you guys can take a look at it, but right now in this video we are not going to look at VRF coordinator. We'll be using a simple counter for this, but this counter itself is a on-chain counter where we'll store the count variable in the chain, and we'll get it and we'll implement it for every NFT mint we are doing. Maybe what I can do is like I can just create a marketplace contract, a factory contract, and I'll be minting multiple contracts with this same counter so that you guys will understand what I'm talking about. So that being said, I think we've been speaking a lot. let's get into some programming. So we need a pragma in every contract file, and what is the pragma I'll be using? So it says like use anything above 8.0. So when you look at the TS file, there is something called a version, Solidity. So it says like it's going to use the compiler 0.8.4, which means anything below 0.8.4 will actually be compiled with that compiler. So that's what it resembles. So what I'm going to do is I'm going to change it a little bit. Anyway, I'll be deleting this creator contract. We'll not be using it anymore. So what I'll be doing is like anything greater than and equal to 0.6.0 and anything less than or equal to 0.8.0. So basically this is what I use. The error that's showing is like my local machine has 0.8.12. Let's ignore that. Okay? It doesn't matter. And so like I said before, we'll be using openzeppelin implementation of these contracts. Also for the tokenId we're going to use a counter. So even openzeppelin has a counter for it, counter implementation for that. So to include openzeppelin in our project, what I'm going to do is like there is this npm package which we can install. So that I'm going to do yarn openzeppelin /contracts at I'm going to be using a very particular version because it's basically a stable version and a bug free. So I don't know, using the other version has some kind of a bug in it. 0.7.2. I think this is correct. Let's check. Okay. Let me spell it out. While that is getting installed, let's go ahead with the development. So I think before going into the actual contract, the NFT contract development, we need this counter which I spoke about. So let's first create the counter. What I'm going to do is I'm going to create a folder. I'm going to create an interface. And I'm going to create a counter file basically. So in the let me copy this. This should be so the interface is basically going to have just count method and the increment method. Going to be external. This is going to return new int. We'll keep it simple for now. We're also going to have an increment function. The increment function is where we actually do the increment operation. We'll do the actual counter implementation. counter is going to have count variable, and it's going to have the human function. Okay, when I call the count function here, it's going to return the actual value from the count variable. And the increment is going to be like, it's going to increment the count variable. So this count is state variable stored in the blockchain. The openzeppelin package of installed. You can just go and check the openzeppelin from our node modules directly. So it's just like in the utilities we have something called a counter. So this is the actual counter which we are going to use. Or there is another way of doing counter, which we can use our own implementation. For simplicity, what we'll do is like we'll use our own implementation of the counter. For that, we need to first deploy this counter contract into our blockchain, and we need the address of this counter contract. So I'll show you guys how to do it. Let's get started with our actual implementation. So what I'm doing is like I'm just taking the ERC721 from openzeppelin contracts. So it's going to reside inside the token. In the token we have the 721 implementation. So I'll be inheriting this 721 contract. I'll be changing few variables here like name and the symbol, and I'll also be using the set tokenURI. Yeah, this one. It's going to set the tokenURI to a tokenId. This tokenId is the counter value which I'm getting from the blockchain, and I'm also going to create another function called create. It's going to actually mint the token. There is another method called mint. This mint is where we're actually going to create the token and mint it in the blockchain. So before that, let's deploy our counter contract. To do that, we wrote the deploy script. We might keep the script as a template for us. Create a new file. This counter, and just copy the content and paste it. So there is this get contract factory from the ethers library. So when you go to the ethers library documentation, it's just like it's gonna read the ethers project. Basically, it's gonna create the contract, and it's basically like using the factory contract. A factory method to deploy the contract. So there is contract factory. So it's going to create an instance of our interface and the bytecode which we're going to supply. So this bytecode is going to come from the compiled file which I already showed you guys, like in the artifacts. For now, we don't have an artifact for the counter because we didn't compile the project yet. We'll do that in a moment. But we'll set up all the deployment script. So to deploy a contract, I think we don't need anything. We haven't defined the constructor. error is because yeah. So this deployed function will actually return the address, which you can use it here. We need this address because just by using the address we're going to interface with the contract counter contract. Let's go and deploy this. Before that, I think we need to fix the errors here. What I'm going to do is I'm going to split this video into two. Like first I will deploy the counter, and then I'll take the address. Then in the next video I'll just create the contract. It's going too long for us now. Let me deploy the counter now. So like I said, to deploy a contract I just need to call the script with the network, appropriate network. Before that I need to compile it. So when I compile it, there will be a JSON file created in the artifacts directory. Okay, so it says like the version in the pragma doesn't match the compiler version. Okay, so in order to fix this issue, what we need to do is like we need to add the version that can compile a contract file within the specified pragma. To do that, we can go to the Solidity here. So the simple thing what I can do is like I can just change this into 0.8.0, or I can add another version for the Solidity here. First I'll just change the version here, then I'll try to add another version. Okay, we'll add a different version. So Solidity basically what Hardhat does is like you can add multiple versions in a single project. So here I can add something like compilers. So basically it's an array. In our case, what I'm going to do is I'm going to add the version 0.3.0. And I'm also going to add version 6.2, because anything above 6.0 will actually do the job. So okay, I think now this should work fine. We do not need this 8.0. I've added this for our, maybe if we have a contract later. So what it will do is like it will actually, I think I have 6.2 in my local machine. If it doesn't, it will actually download the 6.2 and use that version of the compiler to compile our contracts. So what we are going to do now is we're going to deploy the counter contract. So for that, like I said, we need to run the script mentioning the network. The network is Mumbai. It's in the script directory, and it's the counter.ts. I can say something starting Mumbai. Where is it? I think we need to get network. I think it's actually networks. So so what I gave is like Hardhat run network Mumbai. Looks if this doesn't work, we can show it. Let me go to the maybe take this. I think maybe because of this contract. I'm just showing you guys like how what kind of error arises when you're doing this. So that we know how to solve this. Maybe I can just go ahead and check the file that I changes to not there is anything missing. The bracket, if there is something problem with the brackets, so like the linter will like spit it out. So I don't see anything wrong with that. Or there might be something wrong with the deployment script. Let's check. I don't see anything wrong with the deployment script. Okay, everything's fine now. Maybe we'll try this once again. I think it's working now. Maybe. To test this, there are like multiple ways to test the contract. One is we can write the test script, which is very easiest thing that we can do. Another one is like I can just directly use the JavaScript console and interact with the contract like this. The address is here. Copy this address. So just go ahead and check the contract. Basically, it's not going to show us anything here. So what I'm going to do is like, yeah, let's use JavaScript console and use the ethos library, and we'll try counter and we'll see whether the counter is working. So to do that, what we can do is like sh console. And the network is Mumbai. It's very similar to what we are seeing here in the in the deployment script. We need not do the import in the console. But what we can do is like we can just directly use the ethos library and use the contract factory. So here it is. So what I was trying to say is like the same thing what we did in the deployment script. You get contract factory. The name of the contract is counter. That's what I'm giving here, and just ignore the undefined for now, because we are not handling any promises here. So, counter dot. Here instead of using deploy, what we need to do is we need to use something called an attach. that I know this factory, I mean the counter, is going to attach to this, the deployed contract. So I'm going to pass in the address here. Copy. Okay. So when I do that, let's print what's there behind that. The counter is going to actually print the interface, which we are going to use to interact with the contract. So if you guys remember, we defined an increment method, and there is a public variable called counter. This is going to have a getter function, the same name like the count. We look for that function. Here it is. So there is a function called count. There is a function called increment. So if we don't give any default value in Solidity, it's gonna assign the default, for an integer it will assign default as 0. So the counter has to be in the 0 state. So let's see what it is. I think this will not print anything like it. Yeah. It says like basically we are having a big number with a value of 0. So what we can do is like, let's call the increment method, and let's print the count. So what I'm actually doing here is like, when I say increment, I'm just creating I'm just running a transaction. So this is the transaction hash. I can just actually go ahead and look in the polygon scan with that transaction. Maybe, yeah, let's just look at the transaction itself. It's actually been created. Maybe I can just look at my account and see what are all the transactions that I made using this account. So it says 4 minutes ago I created this contract. The count call will not be recorded in the transactions because we are just reading the variable, so that thing will not be recorded. So let's refresh the page again. Polygon is seriously slow. The test note is slow. Or were we using a different account? Okay. From the same account. Yeah. Refresh the page again. Okay, so I've supplied an increment method from this account to the contract. So I go to the contract, it's gonna say like the contract creation this time. So we open this transaction. This transaction actually doesn't display anything here in the timestamp, in the contract methods. But basically this is an increment call. So once the increment call is done, let's check the count. Now the count should be 1. Yeah. It's going to stay in the state of 1 because we are not going to reset anything here. So if we use the counter for the next time, it's going to say like, it's going to count, the count variable is going to be 1, and if we increment it, it's going to stay 2. So what we'll be doing is like, before minting an NFT, we are going to set a tokenId. We'll increment the counter and we'll just use that incremented value and set that value as a tokenId. Maybe in the next video we'll do that. I just wanted to keep this video shorter and not drain you guys with a lot of information. So to summarize, what we saw today is like, now in the video is like, we just did a setup. First we started off with the Alchemy. We created an app there. We took the API key. We added in our env file. We are now going to open the env file. So, from that, what we did is like, we added our network here to the network which we are going to deploy, and we also added our version here based on the Solidity version we are using, and then we tried deploying this greeter contract for testing the setup. and then we created a counter contract. In the counter contract, we created an interface with count and increment. I'll show you guys why we created an interface later when we are doing the actual NFT contract. I just commented this out. We'll let it do to the next tutorial. So in the counter, I actually created an incrementer. Simple as that. This is the very simple tutorial that we can create. And then I did this deployment script. It's basically a copy paste of the actual deployment script that they gave. And then I just deployed the counter. Then we used our JavaScript console to actually go over, test how to attach to a contract that has been deployed and how to interact with it. So that's what we did. In the next tutorial, what we are going to do is we are going to use this contract, the counter contract, and we are going to use that very value that's giving us a token ID, and then we're going to use that token ID and store the token URL. The token URL which I showed you was from the IPFS. So when we actually deploy the contract, it's going to have the actual decentralized metadata in it. So it's not unique in a way that we can't say it's unique, because still there are a lot of things to consider, but to keep things very simple, I'm just trying to do it this way. Thank you. Let's catch up in the next tutorial.